All right, getting with that final page. Your friends try a social experiment of a flash mob. Only 4 of them know at a time. They want to keep it a secret, and the objective is for each person to share with only 3 people who don't already know. The next day, those 3 people tell 3 more people, and so on. How many people will be in the flash mob on day 5? What I'm going to do is set it up with no formula. I'm going to follow in the formula, but it's set up with no formula. So you start out with 4 people, and they're each going to tell 3 people that the next day. Day 5, well, the first day. And we're going to go 5 days. So times 3. So 12 people would know the first day. 36 people would know the second day. 108 people would know the third day. You're multiplying by 3 each time. So we're going to take 4 and we're going to multiply it by 3 5 times. All right? Assuming that they told 3 people on the first day. So 4 times 3 to the 5th, 972 people. If you assume that the other way, and it going to want to ask for clarification, if you assume the other way, and we have it like this, 3 to the 4th, you're going to get 324. So if they started on the first day with 4 people, and they started telling people on the second day, you would have 324 people. If they told those 3 people on the first day, you'd have 972. Graphing these, you've got, we want to get the equation to where we can start getting some points. In this case, they both have a 5x on both sides, so I'm going to subtract. It'll cancel out, and you'll get y is equal to -6. So I'm going to pick some points where y is equal to -6. It does not matter what my x is. I'm just going to get some points where y is equal to -6. How about 5, 0, and -5? There's some points, and if you'll notice, it'll make a nice line for us. We can graph that line using our points. On 41, same thing. I'm going to distribute the 3. 3x plus 3 is equal to 3x plus y. They both have or 3x plus 9 rather. Watch that distribution. They both have a 3x, so subtract that from both sides, and I'll get y is equal to 9. Just like on the front of our review, I'm going to take and make some points so I can graph. Y is equal to 9. Any x points will work, so I'll pick 5, 0, and -5 to get a nice wide line. Here is the 9, and I'll get a fantastic horizontal line there at y equal 9. All right, in your own words, 2 methods of determining if something's a function or not. All right, so each x has exactly 1 y. That's on tables and stuff where you've got the tables like this. Each x has exactly 1 y. So this one's a function because anytime I pick 5 for x, I get a 9 for y. Every time I pick 0 for x, I get a 9 for y. What would make it not a function in this case is if I had a 5 for x and I had another choice for y, like an 8. That's what makes it not a function. So as long as each x has only 1 y choice, you're good. The other one, vertical line test. And you'd have to, you'd write this bad boy out. But the vertical line test, if you have a graph and you're not looking at a table, dropping that vertical line allows you to determine quickly whether or not you've got more than 1 y choice. So as an example, if I had some of this action in a graph, at x equal -5, I have 3 choices I could use for y. So if I said, what's the function value when x is equal to -5? You have options. Those options are what make it not a function. If there are no options, if there's only 1 value, like example over here, there's only 1 choice you can make at x equal -5, that's a function. This one's not. You have multiple choices. Discrete or continuous? Discrete is individual items. Individual items. So like if you're selling iPhones or cupcakes or you have puzzle pieces, you have to sell whole amounts of those items. Washing cars. You can't wash a fraction of a car and get paid for it. You got to do the whole thing. Whereas continuous, you have pieces. You can cut these things up into very small pieces. As small as you can measure, you can cut it up. As an example, if you are traveling in a car, all right, you can travel for 5 minutes. I guess that's more of a bus. But you can travel for 5 minutes. You could travel for 4 minutes. You could travel for 4 minutes and 35 seconds. You can travel for 4 minutes, 35 seconds and 72 hundredths. You can cut those pieces down very small and get some, get some incredibly small increments of increasing, which allows you to make a curve. So if I'm doing distance versus time, and this is my time and this is my distance, I can connect those dots because time can move forward in very small pieces. All of those points are there. Whereas with discrete and continuous, if I am doing, if I have monkeys because there are some bananas hanging out in my room or something like that, as there are more bananas, there are more monkeys. But we can't connect the dots because you can't have half a monkey. So it's only whole dots. That's the difference between discrete, they're individual items, and continuous. You can cut those up into small pieces as small as you can measure. Create a custom graph and write a few sentences relating your graph to a situation of your choosing. Okay. So I have, this will be time, this will be distance, and we'll go like this. And we'll go, Timmy walks away. Thinks he left his keys. Goes back to get keys. All right, so you're leaving your house. You're like, yeah, I'm going to school. Oh, did I forget my keys? I forgot my keys. I'm going to go back to my house. And that could be your distance time graph. All right. Describe processes between problems like 26. This is the f of x problem. So if you get f of x, if you get f of 3, they want you to put in 3 for x and solve. If you get f of x is equal to 3, they want you to set it equal to x, or set your equation equal to 3 and solve for x. Key difference. You've got that all worked out on those videos before if you want to see a little bit better example. Anyway, those are your two differences of function notation. Good luck on the test.